Hi students, welcome back. Today we are going to solve the validate binary search tree problem on LeetCode. So this is a very simple problem. We are given a root of a binary tree and we have to determine if it is a valid binary search tree. So how is a binary search tree defined? Binary tree only has two nodes, left and right, and binary search tree is where left of the tree is always less than the nodes key and right is always greater than the nodes key. Okay, so for example, if in this case, this is a valid binary search tree because all the nodes on the left are less than root and all the nodes on the right are greater than root. Let's look at another example. Here, if you see, all the nodes on the left are less than root and all the nodes on the right are not greater than root. 4 is less than 5, which is why this is not a valid binary search tree. But if you see only this subtree, this is a valid binary search tree. But if you look at the complete tree, it is not because this is less than this. Okay, let's look at how we can solve this. So we will use recursion to solve this. This is okay. Let's define. The basic definition is if left tree is a binary search tree and right tree is a binary search tree, and if the current node's value is greater than everything on its left and less than everything on its right, then it is a binary search tree. Remember, it shouldn't be equal to as well. It should be less than and greater than. So let's write a recursive function to look for validity of a binary tree. Let's say, okay, we have a node. Let's say we know the min and max values of this or the boundaries of this tree. Okay, so now what are the boundary conditions? If root is null, that means there is nothing in the tree, then it is a valid binary search tree, obviously. Okay, then if root dot val is root dot val should be greater than 1 min if it is less than or equal to min, or if root dot val is greater than or equal to max. So at any point, if root dot val is not less than the left side and not greater than the right side, then we return false. So the root value should be always less than the minimum, no, greater than the minimum and less than the maximum. It should be in between these two min and max values. If it is not the case, then we return false. Now, so we have checked for all the boundary conditions. Now, what is the actual case? So now we know that the root is in the current valid boundary conditions and all that. We have to check for the left and right. Only when left and right are also valid binary trees, then we call it a valid binary search tree. Okay, so for left, the minimum value doesn't change. Okay, you're going left, so its maximum value is the value of the current node. It can't go beyond that. That is why the max value for the left is root dot var. Similarly, for right, it can't go. The minimum value is root dot val. It can't go less than that. If it goes less than that, that means it's not valid. Okay. So if we find that the left tree is a valid binary search tree and all its values are less than root dot val, and right tree is a binary search tree and all its values are greater than root dot val, then it is a valid tree. Okay. Now let's call this function in the main method. Valid BST. We have root. How do we get min and max values? Let's start with the maximum values possible. Okay, let's compile this and see. Okay, so looks like it worked. Let's submit it. Yeah, so it worked fine. So what will be the time complexity? We are looking at each node at least once, so it will be order of n. Okay, that's all we have for this video. Thank you for watching.